All right, so we're going to cover 1.3, which is basic trigonometric functions. And we want to look at this situation here where we're building a ramp where the ramp has to get to a height of 8 feet. But because it's for wheelchairs, we can't have that angle be too steep. And so the angle from the ground must be about 5 degrees. And we want to figure out how long this ramp should be. So we have this 8-foot wall. And if I build a ramp to get to the top of that, this angle right here with the ground can't be more than 5 degrees. Okay, so how could we figure out how long this ramp is? And that's what we want to explore in this section, to figure out how long this ramp could be. Now we're going to learn about several, or 6 in this case, trig functions. We have the sine of angle alpha equals opposite over hypotenuse. Cosine of alpha equals adjacent over hypotenuse. Tangent of alpha equals opposite over adjacent. Cosecant of alpha equals hypotenuse over opposite. Secant of alpha equals hypotenuse over adjacent. And cotangent of alpha equals adjacent over hypotenuse. So we have these functions, and if we're looking here at this diagram here, one way we can remember this is so, ka, toa. And so if I wanted to find the sine of angle A, if I was standing here at angle A, opposite of me would be side A. The hypotenuse of this triangle is C. So the ratio here would be sine of angle A equals A over C. If I wanted to find the cosine of this angle, A, standing at angle A, adjacent to angle A is side B. The hypotenuse is still C. If I wanted to find the tangent of angle A, opposite of angle A is side A. Adjacent to angle A is B. And so that's sine, cosine, tangent. Now, the cosecant of those angles would be just the reciprocal of sine. And sometimes it's easier to cross multiply or solve a triangle if we use the cosecant. The secant of angle A is just going to be the reciprocal here, C over B. And the cotangent of angle A is just going to be the reciprocal, which is B over A. So using SOHCAHTOA helps us find sine, cosine, tangent, and then cosecant, secant, and cotangent. If we can just remember that cosecant is the inverse of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. That helps us find those ratios. Now this would change if I moved my point of reference to point B, because now angle side A is no longer opposite. Now this is the adjacent leg, and this is the opposite leg. The hypotenuse doesn't change, but the adjacent and opposite sides change if you were standing at angle B. So let's look at this triangle here. Example 1. Okay, we have this triangle here, and we are trying to figure out sine, cosine, tangent, cosecant, secant, and cotangent. Okay, for angle T. Okay, so we're standing right here at angle T. Opposite and adjacent are really easy to see, but we're missing a side. So the first thing we need to do is figure out what that hypotenuse is. So we're going to square 8. 8 squared is 64. 15 squared is 225. And if we add those together, we get 289 equals h squared. 289 equals h squared. And the square root of 289 is 17. So let's first find the sine. So the sine of angle T, opposite of angle T, is 15. Opposite of angle T is 15. And the hypotenuse is 17. Now right away, I can find the cosecant of T, which is just the reciprocal of that. Next, let's find cosine. So using so, ka, toa, we have cosine of angle T equals the adjacent side, which is 8 over the hypotenuse, which is 17. Right away, I can find the secant of angle T is 17 over 8. Okay? So now let's find the tangent. TOA, opposite over adjacent. So the tangent of angle T is opposite over adjacent, which is 15 over 8. The cotangent of angle T is the reciprocal of that, which is 8 over 15. And we found all 6 ratios. Now, trigonometric functions are useful because the ratios will always be the same as long as the angles are the same. Consider the similar triangles below. So when we're looking at this diagram here, we can see that we have 2 triangles in this picture. We have the small triangle, and we have the large triangle. The large triangle, I'm going to do my best to copy that, has a side that is 8 and 6. We have a smaller triangle, so this side here goes from here to here. And then on the smaller triangle, we have 3 and 4. If we find, for example, the tangent of this angle down here, let's call it theta, okay? If we find the tangent of theta, that's opposite over adjacent, that's 6 over 8. If I find the tangent of theta, remember theta is this angle here, so it's the same in both triangles, equals opposite over adjacent. Notice that this reduces, if I divide this by 2 and divide this by 2, this reduces to 3 over 4. And so the tangent, it doesn't matter the length of the sides, is a constant ratio for that angle. And like I said earlier, so, ka, toa is an easy way to remember. You just have to remember that the S stands for sine, the O stands for opposite, the H stands for hypotenuse, and when we have ka, this stands for cosine. And then when we have toa, this stands for tangent. The A always stands for adjacent. And that's an easy way to remember the sine functions. Okay. So let's go ahead and find all 6 trigonometric functions for the angle alpha, where we have 1 and 4 as the length of the legs. First thing we're going to want to do is find the missing side again. Square root, square root. And so we have the missing side here is 17. So this is radical 17. And so if I want to find sine of alpha, I'm going to do opposite over hypotenuse, 1 over the square root of 17. But the square root of 17 can't stay on the denominator, so I have to rationalize that. So I multiply the top and the bottom by the square root of 17. I get radical 17 over 17. How do I know the bottom is 17? Well, the square root times the square root undoes the square root. When I multiply radical 17 times radical 17, it becomes the square root of 289, which is this 17. Okay. Next, let's find the cosine of alpha. Cosine is adjacent over hypotenuse. So adjacent to this angle here, alpha, is 4. So we have 4 over square root of 17. Multiply and multiply the top and the bottom by the denominator. We get 4 square root of 17 over 17 for this one. Next, we have the tangent of alpha, which is opposite over adjacent. So that's 1 over 4. And then we need to find the secant, let's do cosecant of alpha. Now I can flip over, I can find the reciprocal of radical 17 over 17, but earlier we found that the sine of alpha was this right here before we rationalized it. So if I flip that, I see that I get the square root of 17 over 17, which is just the square root of 17. So the cosecant is just the square root of 17. Let's do the secant of alpha. Again, earlier I found that I had 4 over the square root of 17. So this will be the square root of 17 over 4. And then last, I want to find the cotangent. The cotangent is just the reciprocal of the tangent, so it equals 4. Okay, let's do example 3 from section 1.3. So we want to find the exact values for all 6 trigonometric functions for angle beta of the right triangle below. So of course we always are missing a side, so we got to find that missing side. We got to use the Pythagorean theorem to find the missing side, and I do some math, and I find that I got 8 squared plus 12 squared equals c squared. I'm going to add 64 plus 144. I get 208. And if I square root 208, I end up getting that 208 is 16 times 13. which is a 16 is a perfect square. I just happened to get that on this first time. You could break it down to its primes and find all the perfect squares that way. So I get 4 radical 13 as the hypotenuse. Okay, so this hypotenuse is 4 radical 13. And now I'm going to go through and find everything for angle beta. So I have to use angle beta as my reference point. Okay, so angle beta, sine, opposite over hypotenuse. Opposite, it sometimes helps to label the triangle opposite, adjacent, and hypotenuse if I'm standing at angle beta. Okay, opposite over hypotenuse. And then I'm going to write cosecant right here. And I'm going to come back and I'm going to simplify all these later because this problem is going to be a long one. I'm going to write that cosecant right next to it. Now I'm going to go and I'm going to give myself some space and write cosine, which is adjacent over hypotenuse, 8 over the hypotenuse, and I'll simplify that later. And then I'm going to write secant of beta while I'm here, since they're related, 4 radical 13 over 8, okay? And then I'm going to do tangent of beta, which is opposite over adjacent, 12 over 8, and cotangent of beta, which is 8 over 12. Now I have to simplify all of these. I have to simplify these. So I'm going to multiply here the numerator and denominator by radical 13. And I'm going to get 12 radical 13. Radical 13 times radical 13 is this 13. So 4 times 13. 12 divided by 4 is 3, so that helps me with that. So I get 3 radical 13 over 13. Now cosecant, 4 and 12 reduce, and 4 goes into 12 3 times. Okay, so here, again, I can choose to reduce this first. Maybe that's easier. We get 2 over the square root of 13. Multiply the top and the bottom times the square root of 13. And I end up with 2 root 13 over 13. And here, the 4 and the 8 reduce. So I get radical 13 over 2. And then for tangent, that is just reducing, dividing by 4, so that I get 3 over 2 as tangent of beta. And cotangent is going to be 2 over 3. And so now I have all 6 trig functions simplified. Example 4, we're looking at a right triangle. The sine of angle A is 9 over 14. But I want to find the 5 other trig functions. So it's going to help to draw a triangle here and make one of the angles angle A. And we'll remember sine, so, is opposite over hypotenuse. So the opposite is 9. This side is 41. So we want to find this side right here. So that's x squared plus 9 squared. We want to do the 2 legs. These legs, x squared plus 9 squared equals 41 squared. So we go back and we do 41 squared, x squared plus 81 And then I need a calculator to do 41 squared. So I'm going to do 41 squared is 1,681. I'm going to subtract 81 from both sides. I get 1,600. Square root, square root. And I get that the missing side is 40. So now I know this side right here is actually 40. Now I can find the other trig functions. So I'm going to write sine of A equals 9 over 41 so that I can find cosecant of A, which equals 41 over 9. And then I'm going to write cosine of A. Again, we're standing right here at angle A. So adjacent to angle A is 40. So I'm going to write 40 over hypotenuse 41. And write the secant of angle A equals 41 over 40. And then last, tangent of angle A. Angle A, opposite of angle A is 9. Adjacent to angle A is 40. So that's 9 over 40. Cotangent of A is 40 over 9. And that would be our 5 trig functions that we're missing for angle A.